Reactivity is all about the art of dealing with changing data in such a way that you don't have to worry too much about the processing part when data changes. I think if you want to be formal, there's probably some dictionary or encyclopedic definition of reactivity, which will tell you it's about being declarative in a programming sense, like explaining the logic without imperatively saying what to do at every step of a data transformation, but of explaining the rules in like a functional programming sense, explaining what the transformation should be. And that's about the essence. So it's really combining the ability to be declarative with the ability to process data changes automatically in an efficient way. So that's a notion known as incrementality. It's the idea that when data changes, you don't have to do a full recomputation of all the models, of all the things that you've designed in your data pipeline or in your data science project. You just do a minimal recomputation to react to the way data changes. So I guess the most best known example of a reactive system out there is your spreadsheet. Call it Excel sheets, whatever is your preferred software. You define the rules on the data, and when the data changes, the cells update. So this is like one example. It's a data processing example. It's not one that scales very well, but it's an example of data processing. And actually, since spreadsheets came in, I think nobody has been able to fully replicate the success of this type of approach at scale. And we come with our attempt. I should say that reactivity is a concept that's very well known, very familiar to front-end developers. If you've worked with JavaScript, TypeScript.
Yeah, it's even probably the most famous framework right now for front-end development is called React.js.
It is. And the others that don't have React in their name are reactive nonetheless. So all of them are. And like the kind of place this has got front-end developers to is that when designing a front-end system, you don't have to do as much event handling as you would do 15 years back. So some of you may remember having to write things like on-click events to describe the state change of a button, when you click, but you had to do it and so on. And these days in front-end development, you don't do it that much. Surprisingly, in data processing, even data processing at scale, if you want to work in a real-time setup, you want to work with data that changes or with streams of event data, a lot of the time you still find yourself doing the equivalent of on-click do or something like this. The backend equivalent is on data change event or on arrival of a certain packet of data do. And this is something that has to be done behind the scenes, no question about it. It's just that we don't necessarily want the developer, be it the data engineer or the data scientist, to be exposed to the pain of doing this type of on something event processing. After they've already had to put a lot of effort to design their system just to get their job done to create a model or something.
So it seems relatively straightforward to me to understand. In the case of a user interface, we have a browser app that is reactive to somebody adjusting how wide the browser is, or whether they come in on a mobile browser or a tablet or a desktop, that the website automatically adjusts, or as you're saying, to behaviors, to somebody clicking on something and the application reacting to that. In the case of data changing, what does that mean? Like, how do the data change that are flowing into a machine learning system? Like the machine learning system, it could be handling different kinds of data types, or what is it? What does it mean when the data changes?
So the most straightforward setup, I'd say, is when the data type does not change. You just have to deal with new data of the same type, just data that you haven't seen before. If you're a data scientist, like the ideal world is when the data sample that you're working with
Hmm.
is the
Hmm.
actual data that will
Hmm.
be that has to be analyzed.
Hmm. Hmm.
When you're in the online ever-changing world where new data comes in, this is never the case that the data sample that you look at the time of designing your model is the one for which you need to do the insight. So in some sense, at least the testing data, the real world testing data is not known to you. Sometimes, even in real world scenarios, it may be the case that the training data, so to speak, is not known to you. So your model is retraining itself or adjusting to new incoming data.
Online
Um,
learning.
Online learning and things like this. So this is the general setup. If you like diagrams, you can picture data inputs on the left, data outputs on the right, and your data pipeline in between. And whatever fresh events come in from input need to be taken into account. If you want to make life fun in an architecture sense, you can also put a human in the loop, somebody who's
Hmm.
providing feedback on how your model is performing and saying, actually, we should tweak this parameter. For example, it's like, today we need to adjust because it's a rather special day or something like this. Some parameter for your forecasting, prediction, anomaly detection model. Or the user can say, actually, in the training data, there was a mistake. And we need to pull out a training data point and say, look, this should never have been trained like this, or the label should have been changed, or a certain class of automated inputs which entered the system may have entered with incorrect values. For example, there was some confusion between M denoting meters and miles. The data that input needs to be rescaled, and you have to sort of unlearn the data that came in previously and relearn with the new data. So anything is kind of possible in the sense of data changes for the system.